All right, well, I'm going to just go ahead and start. We'll make sure we record everything so that anybody who wants to watch it can watch it, but I'm not so far seeing anybody here, but that's okay. So today we're moving on to a new subject, which is user-controlled input, essentially. Let's see, we're going to be taking a look at a few different things here. I do not have a homework posted yet. I started it last night and didn't quite get it finished, but I will get it finished today and post it for you to start working on. Okay, so let's get started here. Open up MATLAB. Today we want to learn how to enter in, or to prompt the user of the computer to enter in some kind of input for the program for MATLAB to use in its programs. And essentially we're going to learn some new commands, some new functions that are built into MATLAB, and learn how what the syntax is and kind of what the restrictions are and other things like this. So let's start off with a very simple function called the input function, and just like normal, make sure that you start your script for entering things in, and I'm not going to start a script here. I'm going to leave that for you to do. Make sure you start an M file to take notes on lab or this class for today, and so you can turn it into your homework. But the first thing I'm going to do is I'm going to go ahead and put in help input. And let's see what this function is all about. So the input function prompts the user for input, prompts for user input, and you're going to put in some kind of value in here, and it's going to be a string. It says displays the prompt string on the screen. It waits for input from the keyboard, evaluates any expressions in the input, and returns the value of the result. And then so essentially we've got a single thing that we can put into the input function, but then here we have two things. So it has prompt, and then it has this quote S after the comma. And in this one, it's going to we're going to ask the input to input something essentially, and it's going to put that thing into the variable S. So let's try to use this in a couple of different situations and see if we can make it work. So let's say input, for example, and it's going to be a string, so I'm going to put it in quotes. Enter the date here, for example. So let's see what this gives me. When I hit enter, in the command window here it says enter the date. And so I enter the date. If I'm going to enter the date, it's the 24th, for example. It's going to enter that into the answer for input. The answer for input is now 24. However, if I change this, enter the date, and then I put a comma here, and then I put in a string, let's say the date is February, like that, and let's go ahead and hit enter on that and see what happens. So apparently it doesn't like that. Let's do that. Let's do that. Now let's see here. Oh, so you actually have to use. Oh, I see what it is. Okay, so for the second one, what I need to do is I need to put in a quote. I need to put in quote S here, and then I need to assign it outside of input. So, always good to look at. It's always really good to look at the examples here, because up here it says string equals input prompt, comma, and then it's putting this, whatever this thing returns, into str here. So we need to call this date, for example. If I call this date equals input, enter the date, comma, and then s in quotes, then I hit enter, it says enter the date, I put in 24, and it says date equals 24. So that's how we do that. I think that can be done this way as well. Let's see if that's true. Let's see, date equals input into the date 24. Yeah, you can do it that way as well. Let's see here. So reply, input, do you want more? This one goes in true, if s empty, reply. Okay, so in this particular one, they're actually writing a little code here. We'll save that for a little bit later here, because this is actually using an if-then statement. We don't want to use that. So you don't actually have to use this s thing until later. So let's not worry about that. But the input function is very simple. In the way that we're going to use it, if you use the input function and you put in a little phrase in quotes, then it's going to prompt the user. Now, the thing I don't like about this though is that it says enter the date 24 right here. I'd like to have some space there, so let's put some space in there. If I use this here, enter the date, and then I put in a space or two, then it will actually leave that space after enter the date. So then I put in 24, and that's kind of nice. You can also put in different things, like I could put in a dash in there. Enter the date 24. And it's just kind of up to you how you want to do this, how you want to make this work out. The point being that you want it to look nice on the screen, so you're entering the date 24, comes out as 24. What if we prompt the user to enter the date and they enter in February 24th, for example? It's not expecting you to put in a string, so letters are not recognized, spaces will not be recognized. It's looking for a number in this particular case. And so if we wanted to enter something else, we're going to have to do it differently. And the way that you do that is you enter a string. So let's say we want to say that it's February 24th. I can put it in as February 24th, like this, in quotes, and then it recognizes that, because MATLAB, when you put things into quotes, it recognizes that you're putting in a string entry, or you're putting in letters and spaces and numbers and other things all mixed together, and then it will interpret that as the stuff that's in between here is a string, and so it will print it out as a string. So if I wanted to change this to make it a little bit more user-friendly, I might say enter the date in single quotes Oops, that's not what I meant to do. Let's actually get rid of this. So if I go back to my original one here, enter the date, and I just put some instructions in here, for example, in single quotes, then people will know to put in single quotes because it says so, and then you put in single quotes, and then you can put anything you want. You could put in 2/24/16, for example, and if you put single quotes around it, whoops. If you put single quotes around it, like this, 2-24-16, then it'll do it just like you want to. The date is 2/24/16. And so on and so forth. So, input function allows you to input numbers. It'll allow you to put in strings, but it'll also allow you to put in an array. So let's change my thing here to enter an array of numbers of your choice. Oops. And then I'm going to just put here, be sure to use square brackets. To remind people that you need to use square brackets when you're using MATLAB. Now this is going to turn out okay. If I hit enter, it's going to give me this line here. It's a fairly long line though. Maybe I want to separate these two lines. To separate these two lines, I can actually go back to my information on this thing, and it says that if I use the \n, it will give me a new line inside of here. So if I do, I'm going to finish up this really quick here. I'm going to put in my array of 4 or something like that, and it returns date 4 because I never changed that. But if I change all of this now, and I put a new line here, for example, if I put \new line right there, and then I change this date to, let's call this array. Let's call it user array. User array, like this. Hit enter. And then it says enter an array of brackets, an array of numbers of your choice. Be sure to use square brackets. And then I enter my array, whatever I want. Put in some square brackets here. I can enter an array of just about any kind I want, any size I want. I can even enter in different rows for, I can put in 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So I can go ahead and do that and hit return, and it'll enter in that entire array. And you can do other things as well. You could actually put in a square bracket, and then put an array of, random, for example. Put in a random array 9 by 9. I think it'll do this. Let's see. Yep, so it puts in a random array, 9 by 9 random array. So what the input function is doing is it's evaluating whatever you put in here, and then it inputs. So then it puts it into the input. In this case, it's assigning it to user array. So it's a very useful function if you want to start interacting with your user. So, for example, let's do a little example script here. Let's put a new script up here, and let's actually not do a new script. Let's do a new function. So in this particular function, my output arguments, I'm going to call this, let's call this area, and let's call this function area room, for example, maybe. And the input arguments, let's put in length. No, because length is length is actually a function in MATLAB, so we don't want to use that. Let's just use L and W for those things. And then what I'm going to do in here is say that this function will prompt, let's actually give it a title. This function calculate the area of a rectangular room. User inputs length and width. Okay, so that's good enough, I think. So let's go ahead and we're going to have our length and width are going to be inputted here. I think that's correct. There we go, that's better. So we have length and width are going to be inputted, and we're going to use that to calculate the area. So let's say that area is going, let's first start this off with an input function, of course. So let's let L equal input, and then we're going to say, please enter the length of your room. Make sure we put that into quotes. Then I'm going to go ahead and suppress the input there. Suppress the output, rather, of that, so that it doesn't print to the screen. I'll let the width equal input please enter the width of your room. And I do want to have a little bit of space after this, so I'm going to put in a couple of spaces. And maybe I'll put a dash just because it looks nice in both of those. And then after I've used those two, I'm going to calculate the area. Let the area equal length times width. I'm going to use capital W and capital L since I use those to begin with. And we're good to go. We can suppress that as well. And let's save that. Area of room. So let's save it in our workspace that we're in, whatever workspace we're in. I don't know what workspace we're in. Just save it here, that's fine. We'll go down here and we'll go, well, let's go ahead and just run this file. We'll run it here. So it's running area of room. Please enter the length of your room. Let's say it's 45. And the width of our room is 12, maybe. And it gives us, and we actually forgot to suppress the output here. This guy, right? There we go. And let's do that again. Area of room, so 45, 12, and the answer is 540, right? Trying to remember, I think that if we I'm trying to remember. That's okay. Never mind. So this is a little function that prompts the user to do a couple of things, and then uses those inputted results to go ahead and calculate something. Very simple function, but it's now more user interactive. Let's see what else we can do here. Okay, so let's do another example that has even more prompts that we're going to use here. So let's create a new function. Open a new function here. Let's call this one. Let's call this one array. Let's put input arguments of beginning. Let's do spacing, and let's do ending. And let's call this array here. And let's call this small array, little a array. And what this function is going to do, this function builds an array, detailed explanation, user inputs first and last numbers in array and the spacing. So we'll go ahead and do this again. We'll let begin equal input from, let's say, enter the first number in your array. Go ahead and copy this line and we'll use it again. We'll paste it here. Instead of it being begin, we'll call it the end. Ending. We'll enter the last number in our array. And we'll use this again here, paste, but instead of this we'll call it spacing. Enter the spacing between numbers in your array. And then we want to build this array. It looks like this. The array is going to equal we'll start with begin, right? And then we'll put our colon here, we'll put in spacing here, and then we'll put in ending. Right? Go ahead and suppress that. Suppressed everything else. We'll go ahead and save it as array and we'll run it. First number in my array, I'm going to let equal 1. I should probably put a space after that, then 10, and then 1, and it gives me the array 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? I put in 12. Whoops. I do the same thing again. Array, and then 12. Enter. 45. Spacing 0.01 gives me a much bigger array, right? And so on and so forth. So user entry, lots of things you can do with the input function, but it's fairly simple. Excuse me. So let's do a little more let's do a little more complicated one, maybe. Let's open up a new. I like this function feature that just starts it off for me. So let's call this fall. We're gonna create an array. We're gonna create a function that calculates the distance that something falls in a certain amount of time, and let's call this free fall maybe. And we'll have a few different input arguments here. Let's do so let's do gravity. Let's do beginning. Let's do time 1. Let's do time 2 for our 3 variables that we're going to put into this here. We're going to calculate the distance something falls. User inputs gravity constant, beginning time and ending time. So that's kind of an explanation of what we're doing here. And let's start off by asking a question. Let's have the user input into gravity. So let gravity equal let's let gravity equal the input from this question. I'm going to ask a question. What is the gravity constant on the planet you are falling towards? And I don't really like how long that is, so I'm going to break this up into 2. I'm going to go ahead and put a space here, not a space, but a new line, a line break. So what is the gravity constant on the planet you are falling towards? There we go. We're going to go ahead and suppress that output and save here. We'll copy this and we'll paste it again. And then we'll have our time 1. What was the time seconds and when you began falling? So they're going to be measuring the number of seconds here. And time 2, let's copy this one. Okay. Time 2, what was the time on your second hand when you stopped falling? There we go. Okay, so then we're going to do some math here. It turns out that the equation for this looks something like this, where the falling distance is equal to 1/2, so 0.5, times the gravity constant, so we'll do times gravity, and then we multiply by the time squared, but it's actually the time distance squared, the time difference squared. So we have to take time 2, subtract time 1, and 1, and square it. So that is our formula for that, and we'll go ahead and suppress that. And then we'll run it. So we'll save it. Run it. What's the gravity constant on the planet you're falling towards? Well, if I'm falling on Earth, the gravity constant is either 9.8 meters per second or 32 feet per second squared. So I'm gonna do 32 feet because I want to know how many seconds it takes me to fall, how many feet I'm going to fall in a certain number of seconds. So let's say that I start falling at 5 seconds on my watch, and I stop falling in 10 seconds. So that's a 5-second fall. If you fall for 5 seconds on Earth, you're going to fall 400 feet. If you fall for 1 second, let's do this with 1 second. So if it's 32 feet per second, and the gravity, the time in seconds is, I start at 0 and I end at 1, I just fall for 1 second. I fall for 16 feet. Turns out it's a long way that you fall in a second. It's not a short distance. What about a half a second? You fall 32 feet per second. Time is 0 and I'm down to 0.5. Actually, the answer is 4 feet. So a half a second you fall 4 feet. And that's how long your average basketball player falls after they've jumped to their highest height. Most basketball players can jump about 4 feet high or less. Usually it's a little bit less than, it's usually a foot less than 4 feet. Usually it's about 3 feet they can jump. But between 3 and 4 feet is somewhere in there, is somewhere where their jumping vertical is. And so they're in the air for about a half a second going up and about a half a second coming down. So the hang time is only about a second. It's pretty rare for somebody to have a hang time longer than a second. Most of those people are short people who can jump really high. People like Spud Webb I think had a hang time of 1.6 seconds, which was really amazing. Not many people can jump that high. But anyway, it's an interesting one. What if I'm on the moon, though? If I'm the moon and I'm falling, let's see what the difference is. The difference on the moon, your gravitational constant is about it's about 5. So it's about 0.2 times 30, which is about 5 feet per second squared. And the time, let's say if I fall again for 10 seconds on the Earth, if I fell for 10 seconds, then I was falling 400 feet. On the moon, if I fall for 10 seconds, it's only 250 feet. It's quite a bit less. So you can do all kinds of things, all kinds of calculations asking for input from the user. Another thing that you can do is you could even create a graph of this. So let's modify this thing to create a graph. Remember, to create a graph, you not only need numbers, but you need an array of numbers. You need a bunch of numbers. So what I need to do is from these inputs, I need to create arrays of numbers. And I want one array of time numbers and one array of fall numbers. So maybe I create an array of numbers that I'm going to call time, or just t, and I'll let t equal time 1 and then I'll have I'll go ahead and split this into chunks that are about let's say 0.1 big. So I'm going to take steps of 0.1. Actually, let's take test steps of 0.01 just to make it nice and smooth. And then I'm going to have time 2 as my ending number. All right, and I'm going to suppress that. And then fall is going to take all of these numbers here, time 1 and time 2, and multiply them by these things here. We're going to take time 1 minus time 2 and square it, however, so this is a little bit of a problem. We're going to have to do this. That should be okay. Let's try it out and see what happens. Well, then after I've done this, what I want to do is what I want to do is I want to plot this. So let's go ahead and plot. We'll plot time and fall. Let's see what we get. So let's save that. Let's run it. There's a plant. So we're going to go 5. And let's go from 0 to 10. Okay, so we've got a problem here. Oh, because I put in time, not t. So let's save that again and run it again. So 5, 0, 10. And where's our plot? So here's our plot. Let's see if it actually gives us a plot. It didn't give us a plot. So obviously something is missing. So what we do to figure out what we're missing is we look at our... Oh, so the problem is, actually I know what the problem is. The problem is that we didn't create an array that we thought we created here. All we created was an answer 250. We didn't get an answer of a lot of numbers. We want to get a lot of numbers out for each different thing. So what we need to do is go back to our array here, or go back to our function. And we need to create, so here we go. Oh yeah, so instead of using time 2 and time 1, we need to use t here. Okay, so instead of time 1 and time 2, here we're just going to use t here squared. So delete that. That should work for us better. So let's save that and run it. So 5, 0, 10. No, it still doesn't like it. Because we need to do a dot squared here, because we're going to square each part of this. So save that and run it. There we go. 5, 0, 10. Now we're getting somewhere. And where's our plot? Let's look for our plot here. Here's our plot. And this now shows us how many feet we fall every second as we go along. So after 10 seconds we fall 250 feet on the moon, but after just a few seconds, we're falling just a few feet. So you can do all kinds of things with this now. But we didn't suppress, we should have suppressed our t, we did suppress that, we probably, maybe we should suppress our the total output of this thing. Save on. I don't know if it will let me suppress that. But anyway, we can put out all kinds of things. So, let's see here. Okay, let's move on to something new. That is the input function. And that is one of the most used functions for putting stuff into MATLAB. You can put in both strings and numbers and arrays and everything else, so it's a good one. We're going to actually now look at some output functions. There are some output functions, quite a few in fact. One of them being the display function. So let's look at help display and see what we learn there. Quite a bit apparently. So display X, the object X, right, is some kind of thing that you put in there. And when you display it, it's going to display it to your screen. So it'll display a string to your screen. It can display a value to the screen. Let's try it real quick and let's see what happens. Let's just try something simple. Display 5. Well, sure, it can put 5 on the screen. That's pretty easy. But it can also do, for example, a string. I am here, right? And it can do that. Notice that when I put just the number in there, it gives me an answer equals 5. When I put a string in there, it actually just displays the string. And the same thing goes with the display thing. You can put in different lines. I am here. I am thinking. And for I am. Right? Whoops. I didn't do it like I thought I was going to do it. Did I put the end in right? It should have done it, but there's something that I'm missing apparently. Let's go see if it allows us to do that up here where it's apparently does not like that, so let's see if we can put it in a different way. Let's try with two of these. Sometimes that is necessary. No, I guess you can do that. You can't do different lines. It doesn't like it. Let's try this. Display. And what I'm going to do is I'm actually going to take this off of here. Oh, it doesn't like it. Won't let me do it. Okay, so we'll figure that out later if that's possible. I know that it's doable, we just have to figure out how to do it. But the display function is going to essentially allow us to respond to the user input or respond with an answer. So let's say we're doing something like this. Let's actually go up here to one of our functions, the area of the room, for example, and let's, at the end of this, let's put display put in a string the area of the room is, we'll put a little space there and put this on here, and let's see if we can make it work here. Save that, and let's run it. So the length of the room is 5, this is 4, and it says the area of the room is, and then it puts answer equals 20. Now, of course, there is a way to get rid of the answer equals 20. I'm trying to remember what it is, but there is a way to do that. We'll figure it out here eventually. But this is one way to display things on the screen after you've received some input from the user. So it's kind of a way of answering the user. The display function. Let's see, what other... Oh. We can actually do it this way too. We can actually do display area here. So let's actually do this. Let's save this and run it. Let's see what it does for us. Area of my room. So the area of the room is area equals 20. Let's actually put in answer. And let's save that. Okay, so it has to be area. Okay, so anyway, I'm having a hard time figuring out how to get rid of this answer thing, but we'll figure it out eventually. But you can display different things here. Oh, that's what I do. I do this. Okay. Let's try this now. Essentially, it just kind of depends on what you're suppressing in your... And this says that it's going to do this, but it didn't do it, of course. The new version of MATLAB must be slightly different. But if you, as you play around with it, you'll just be able to see how this works, and hopefully between some of us in our sharing tricks and tips document, we can figure that one out for the new MATLAB. Okay, so we've got displaying a very simple thing here. We've got to move on to something a little more complicated. And that means this right here, this example here. Let's say that we want to, up here in our thing, we want to say the area of the room is, and I want to actually put the number into right after this sentence, right after the end of the sentence. The area of the room is 20. If I want to put in the value for area right there, how do I do that? Well, it turns out that display will take a second, it will take a second variable or a second command or a second input. And what you do is you do num to string, and I don't know if you remember this, we covered this one really quickly. It's num2str, it's a function in MATLAB, it's a command in MATLAB. And then inside of this, you put the name of the thing that you want to put in there, the name of the variable, which in our case is area. So if we do num to string area inside of display here, then we will get something different, hopefully. Let's save this and run it. So the area of my room is 4 by 5, and it says it didn't do it. Why didn't it do it? Oh, because I put the comma in. So I can actually enter this straight in. That's actually not a second thing. I can actually just put in the area of the room is, and then what I need to do is change this here. If I try this here, it's not going to work. It's just going to print this out here. So let's save this and show you what's going to happen. And as I'm looking at this, I'm thinking what's going to happen. What's actually going to happen is it's just going to type out num to string area. However, we can take care of that. We can fix that by putting area into an array, actually. We'll build an array with these two things. So we actually take this out of here. We cut it out, and we put it into an array right here. Paste it in here. And then we're going to make an array of two things. The area of the room is one of the things. The other thing is going to be this num to string area command. So now this is going to be a new array. I'm going to call it, let's call it A, for example. Let's just call it A. And then I can display A here, save this and see how it goes. So now it says the area of the room is 20. I didn't leave a space here, so I should probably leave a space here. Save that and run it. And now the area of the room is 20 comes out here. Let's go and learn how to suppress the answer in the functions. So let's do help function. And let's learn how to suppress function output. So we don't get this thing. So special characters, alpha shape, forming F, printf. Spacing line, suppressing output. Format line, spacing, suppressing output. Suppress the output, we use a semicolon, of course. And then in that's not helping me. let's see, for functions, so here we have our function y equals average x is equal to y equals sum of x. It's not, I'm not seeing how to do that, but we'll figure it out eventually. Well, not really, I don't know. Maybe we can do it here really quick. No. Okay, so anyway, let's move on. We've got things to do here. Things to learn. More functions to learn. So now, so far we've learned the function and the display. Let's see, what other things do we need to learn with display? Let's do a simple example here. It's got a little more stuff to it here, but it's not very difficult. So for example, I've got I'm actually not going to even run a function here. I'm just going to run a bunch of lines of code. So let's start with a display of hello. Pretty simple display. That'll be my first line. And then I'll display again. I can't spell. There we go. Say, I am Matt. Or I am Matt, right? Then I could say name equals input who are you? And if we wanted to get really Alice in Wonderland about it, we could say who are you, right? And technically they, in MATLAB, when you do that, they want you to use this formatting or this, but you don't necessarily need to do it. It's going to work either way. But I am going to suppress the input of that, suppress the printing of that to the page here. And then I'm going to put display again and say, hello, whoops, hello. What I'm trying to do here is I'm trying to say hello to this person. But since display only accepts one input, I'm going to make it into an array. And I can do it right within display. I don't actually have to make the array separately like I did before. So if I make the array right inside of display, then I need to put my square brackets right inside of display. And then I put a space, and I'm going to put hello name, right? So that will hopefully work for us here. Let's see if it actually does. And let's run this and see how it works. Save it and run it. So who are you? My name is Jared. It says hello, Jared. And I've obviously got some problems. Who are you? I'll probably put some space after this, maybe a question mark and some space. And then hello, I need some space, right? Maybe I capitalize my I. My display didn't work here. Yeah, it did, I suppose. So save that and run it again. So hello, I am Matt. Who are you? Jared. Right? And it says hello, Jared. Right? So we're starting now to get into interactive programs that are going to start asking for things and giving things back. And it doesn't take much to get really involved in this. Get some really big stuff going on. Okay, so let's look at a new output function. A new output function which is called fprintf. So it's called the formatted print function. And it's essentially similar to the display function, except it gives you a lot more control over what you can do. And I think this is actually where we're going to be able to do things like multiple lines and other things. But it's going to give you options to do more with the things that you display to the screen. So the formatted print function is similar to display, just more. It gives us more control. So, for example, let's start off with this example here: fprintf, and our input here is, again, we're going to go ahead and start off with just inputting some strings. So we're going to put in some quotes. There are cows in the pasture. Right? And we could even say there are 138 cows in the pasture. We could do that. That'd be perfectly fine. We hit enter, and it types out there 138 cows in the pasture. However, what if we wanted to have this work out so that we could type in a number and it would tell us, it would put that number in for 138? So how would we do that? Well, if we were doing that with the display function, we'd have to create an array and then put that number in the middle of the array and put there are in the first thing of the array. So let's actually do it with the display function really quick. So let's create an array here of things. An array of, we'll start with a string, there are, right? And then we put a space, and we would put in, we'll put in number here. And then we put in a space, and we put in another string, cows in the pasture. And maybe we want to put a space before cows and a space after there are. So we have space there. And then we will now have an array that we can call something. We can call this phrase or something. We'll call it the phrase that we're doing. Phrase equals this. And then let's say that we have a number equal to 45. And then phrase equals this thing. And we go ahead to the end of this, close this off. And we have number now and phrase defined. And then we could use display to display this phrase. And I just put in phrase here. And we'll display it. There are, didn't like that for some reason. Something cows in the pasture. Left an open space here for the number thing. Let's see what number actually ended up being here. Number is 45. You should be able to get that number in there, dang it? Let's see. Number, comma. Oops. Let's copy this really quick and redo it properly. Commas in there. So there are, and then I'll put a comma, number, comma, there we go. Hit enter. Let's see what phrase is now. It's still won't do it. But anyway, there is a way we could do a number to string, for example, or something like that, and put that number in there. So if let's do num string num to string, there you go, num to string number, put that in our thing here, paste. Okay, so then let's see what that does for us. So then that tells us the phrases there are 45 calories faster. And then we could do display of that string phrase, right? So anyway, you can do it that way, but it's kind of a long mess to deal with. However, if I actually use my fprintf, I can do it a little bit more concisely. So in fprintf, I can actually put in there are, and then right in this spot here, instead of having to put in, some kind of, instead of having to convert things over, I can actually use a little code. They have a code here for using different kind of notation. We're in string notation now. If I want to switch to decimal notation, for example, I can put a little d here, and then I can put cows in the pasture. And what that tells me is that in the place of that little percentage d, I'm going to put in something that has a different format, a different type of notation. And in that case, it'll be something that has a decimal notation, something that has a number notation to it. And so in that case, I'm actually going to put in the variable number. So I put in comma number here, and that will replace the decimal d with this number, hopefully. I didn't use the right function, so let's fix that. It's fprintf, not fprint. Fprintf, and then it'll type it out. There are 45 cows in the pasture. So it takes essentially something that with display would take 2 or 3 lines, condenses it to 1 line. So, and there are a lot of these different things you can do. You can do fixed point notation, exponential notation, different kinds of things, really. Character notation, string of characters, but anyway. Let's look at an example of using this to return phrase. So up here we did display hello, display I am Matt. Let's see if our fprintf will work up here for this. So I'm going to do fprintf, make sure it's a little f, not capital F. And I'm going to actually try this really quick. I don't know if this works. Yeah. So in fprintf, you can actually skip lines, and that's another thing that I was hoping it would do, because I thought it did. But let's go ahead and do this then. So now we can do all these in a row. So hello, I am Matt, and I'm going to do another line change. And I'm going to say, what is your name, right? Now, to actually get a, we actually want to put this in a new one so that we get an input. So I'm going to erase that. I'm still going to put in an extra line here. I'm going to put that in there, and then the next thing I would do is I would do an input, right? And say, what is your name. Close that. Put the comma. We're assigning this to a string. And I'm going to call this string name equals input. What is your name? In a string variable, put into name. And then, so I go, what is your name? I hit Jared, right? And it says my name is equal to Jared, right? And then I can do fprintf again. fprintf. There we go. And I can say hello. And I want to put in a string now. I'm going to put in a string variable. Before I put in a decimal variable, a decimal object, but I want to put in a string variable, so I'm going to say hello, percent string here. And I'm going to put comma, name. So it puts a name in there, right? And it says hello, Jared, right? Excuse me. Just a little bit simpler than the display command all around. And gives you more options. So that's for the string. The percent decimal is for the decimal notation. Another one that you might use, I'm just trying to think of the field format. Those are the two that you would use the most, I think. Other things that you can do within this command, other than just going to a new line, you can tab. So I could do a \T, and that will tab over. And you can also do a backspace in there. There are other things like different characters that you can put in and different formatting you can do, indenting and other things like this. But those are different things we can do. You can explore all of those in MATLAB. So in this case, it puts a tab in between these two, delineates them. Okay. Let's take a look at some examples here. There's something else we need to learn really quick that I'm... Oh, yeah. Okay. Let's look at one more thing that's kind of interesting with this percent command. So we're going to look at an example really quick. I'm going to do a very simple array. We have x equals 1 to 5. So you just get this very simple array, 1, 2, 3, 4, 5. And then I'm going to use the fprintf command to print out part of this array. And I'm going to put quotes here. So I'm going to be printing it into a string, essentially. I'm going to be changing it into a string. And what MATLAB is going to do is it's going to look at x, it's going to read x as numbers, and then it's going to print it out into a string, where string numbers are different than number numbers, because MATLAB can do math with number numbers, but it can't do math with string numbers. It has to switch them back into real numbers. And it seems like a goofy thing, but MATLAB, when it reads letters, it's reading a code for each letter that is a number. And it knows that that number corresponds to a particular letter. However, when it reads numbers, just like 1, 2, 3, 4, 5, it's actually reading the numbers. in the program. So 1 is a 1 in binary. So when it converts a number into a text number, like going from the number 1 into the text 1, it changes it to a code. So if I typed in, "Who are you? I am number 1," and I typed in 1 in here, that would be a different code to MATLAB than the actual number 1. So you have to be careful when you're dealing with strings and numbers. But if I want to print these off as a string, I could do it using fprintf, but I have to give it a particular command. And that particular command is actually going to be a % again, but we're going to use a notation that is the F notation, called fixed point notation. So it's going to be %F, and before I put in the F, before the F in here, I'm actually going to put in some numbers that are going to give us some parameters to work with. Let's see here, for this particular one, so in this particular one, what we're going to do is we're going to command it for this F command, or this F formatting. We're going to tell MATLAB that we want to put something in here, but we only want to put in a certain amount of it. MATLAB sees this number 1 as a 1.0000 or whatever, and it knows this number out to a very high precision. But we don't necessarily want all of that. We could put all of it, and let's do all of it. If we do %F comma X, and we just plug in X into this, we get all of the digits that MATLAB knows. We get 1.000000, and then we get 2.000000, 3.00. So it shows us the complete number that MATLAB knows for X, and it types it out as a string of numbers. However, if we want to do this so we only see 1, 2, 3, 4, 5, and we don't see all those zeros in that decimal, then we need to choose how many of them we're going to show. Okay. So in this case, we have a total of, it looks like 1, 2, 3, 4, 5, 6. So let's actually only just let's do 1 F. If I put a 1 here, it's going to tell me how many places I want to show X to, I believe. And then if I put a 0.0, it tells me that we're not going to do any, we're going to do 0 decimal place. And let's see if that works. Yes, it does work. It just gives me 1, 2, 3, 4, 5. It just gives me the first thing in the number, and it doesn't give me anything beyond the decimal point. If I do 1.1, no, if I do 2.1, then it's going to show me 2 places, 2 parts of the number, 1 which is beyond the decimal point, and so I get, oh no, it's giving me 2 places beyond the decimal point. What did I do? Yeah. So I want one, so this one shows that I want I'm showing 2 places beyond the decimal point, I suppose, is what it's showing here. No, it's saying I have total of 2 numbers that I can display. That's what it's showing. Okay, so the 2 is the total digits I'm going to display, and the 1 is how many of those are beyond the decimal place. And this is a little confusing because it doesn't print spaces between these numbers. Where if I just type X, it does print spaces because it knows there are spaces between. It puts spaces between each number in the array. If I just do that, but if I just print off X, it doesn't put spaces between them because it just knows that there's a number and then another number and it prints them. If I wanted to show 4 total and have 3 beyond the decimal place, then I could do that too. If I do 4 and I only do 1 beyond the decimal place, let's see what that gives me. It only gives me the first number and then a 0 But then it actually gives me a space because it's extra numbers in front of, there's essentially extra numbers in front of the 2, and in front of the 1, and in front of the 3. So it actually gives me 2 spaces in front of the 1, and then it gives me a 1 and a 0. Then 2 spaces in front of the 2, and then a 2 and a 0. So that's the way that you put spaces in, is you put more things in than you need, and less, essentially give yourself more space to print the number. So I'm giving myself 4 spaces to print the number, but the number only needs 2 spaces because I'm only asking for 1 decimal point. So anyway, that's kind of how we work with this, what is called fixed point notation. So we're fixing where the decimal point is going to be in the numbers that we're bringing into our stream, that we're going to print out to the screen. So if I have a number, and one of the numbers that I have up here previously is the number of cows, right? So I'll use number this time. And I want to print that number using fprintf, I can do so. But if I just use this function to turn it into a fixed point, it will print 45.0 with a lot of zeros, right? However, I can choose how many of those I want to put in. Let's say that I want a total of, I'm only going to do whole number cows, so I want a total of 2 numbers there, and I don't want any decimal points, so I put 2.0, and then I hit enter and I get the number 45. Now the great thing with this is I can actually put other text in here. The number of cows is, and I put that in there, hit enter, and it puts the number in as a string. And I can choose different decimal places and everything else for that. Okay. What else can we put in here? Trying to see how many we have. Okay, so let's do an example here. Let's do a little conversion example. Pretty simple thing here. We're going to make a table. Let's make some arrays. Let's do feet from 1 to 3 maybe. And let's do inches equals feet dot times 12. So essentially we've got an array that goes from 1 to 3 feet and an inches array that goes from 12, 24, 36. And then we can make a table of these things. Table equals feet, inches. We have a little conversion here, right? And if we wanted to do this as a vertical table, we could just do table and invert it, so it's 1 feet to 12 inches, 2 feet to 24 inches, and so on and so forth. Pretty simple stuff. But another way that we could do this is we could actually do an fprintf, and we could get some more precision if we wanted to. Let's say that to do some precision, we do our %f which is our fixed point. And what this %f is going to do is it's going to change the numbers 1, 12, 3, 2, 24, 3, 36 into strings, but it's going to pull out a certain number of decimal points. And we choose how many decimal points. So let's say that we want to have a total number of, total number of digits to be 3, and one of those digits to be beyond the decimal point, and for f there. And then let's see. Let's actually give ourselves some space here. And let's do 4 and 1. And to give ourselves some space, we're going to do percent again. We're going to do 7 and 2 f. So this one would be for the first column. This one would be for the second column. And then we close this out. Now we actually are going to do a new line command as well. So do new line command, and then we'll close this out with the parentheses here. And then we'll say that table is the thing they're supposed to get that from, because table has 2 columns, and so it'll work out hopefully for us. Or 2 rows rather. This is row. We're doing a new line to give us some space as well. So then we go ahead and do this. And you can see here that it's given us 1.0 and it's given us some space before that. So that's the 4. That's the 4th space there. There's 3 spaces here and then the 4th out here. And then this one has got a little bit of space in there because we gave ourselves 7. So it's given us some blank spaces up here. And then we've got 2 decimal places for all these numbers. So 1 foot is 12 inches and 2 foot is 24 inches and so on and so forth going through this table. And when when I did this fprintf, it actually converted this into a column table instead of a row table, because table is actually a row table, right? It converted that into a column. I'm actually not sure why I did that. I'm trying to figure out why I did that. I think I do know actually. What the fprintf command does when it's looking for numbers, it goes through one column at a time. And that's what it did. So it went through this column and then it made a row. And then it went through this column and it made a row. And this column and it made a row. So that's how it did it. So that's just an important thing to know about how the fprintf column goes through numbers, arrays of numbers. So that's making more sense now. All right. Let's see if there's anything else here we can think of to do with fprintf. Can't think of anything else really. You should use both functions. You should learn to use both display and fprintf and what their strengths and weaknesses are. And you should also learn to use the input function while you're going through this week's assignments and homework. We're going to get away from this idea of typing things in and having output to the screen that is typed into the code. We're going to spend this last little... actually, never mind. I have one more thing to do. This last one we're going to do for user input is going to be S input. So this is S input, and let's get some help on that. So no, sorry, not S input. S print F. You want to do help S print F. There we go. Now I've got it. It's not S input, it's S print F. And what this is going to do is going to write formatted data to a string. So stuff that is put in here is now going to become a string instead of a group of numbers, like the F print F, formatted print F. Let's look at an example of this here. Okay, so so this is an example of this. What the fprintf did is that it took things that you wanted to. You essentially had things that sorry, you had things you wanted to display on the screen, and you wanted to take a value and put it into a sentence. Take a number and put it into a sentence, for example. And then display that to the screen. With the sprintf, what they're going to do is they're going to take a value that the computer, that you input into something, and let's see. Oh, excuse me. I'm having a hard time not yawning here. Apparently I'm not doing well at all since I'm yawning. But anyway, let's actually just do this. Just do an example here and we'll show what it does. So sprintf is this thing here. And stands for string print, so it stands for, what does it stand for again? There you go. Format data to string. Formatted data to string. Right. Okay. So it formats data to a string, and we're going to put data. We're going to put data into this thing along with some words that we might type, and it will store that number now as a string, whereas before it was storing strings as numbers. But anyway, that's okay. Let's say some examples of output are and we're going to choose a type of output again. We're going to put these in quotes again because this is something we're going to print to the screen. So we're going to have this F. Let's do 4.2 F for this case. We're going to have 4 total numbers, 2 of which will be on the right side of the decimal point. But the thing that we're going to try to plug in here is going to be some kind of a number value. So let's do like pi times 100, for example, times 1,000. Why not? And we're going to assign this to some variable. Let a equal this thing. So if I type a now, it will give me some examples of output are 3141.59. Right? So it's actually created a string of this phrase, of this a string variable of this phrase that can be used in other places. Where in other cases, I had to actually create the variable, create the string variable myself. But anyway, it's just another thing that can be used here. All right, so now the last couple of parts, last couple of things we want to talk about are entering now other things other than something that you type in or things that questions that you're asking and entering in some kind of answer or something. Particularly, we're going to talk about how to enter in graphical input. So when we type a graph, it creates an array, and we want to be able to use that that array of numbers to do something with it. Let's see if we can. Okay, so we're just going to start off with a simple example. So let's say that x is equal to 5 colon 30. So it gives us all the numbers between 5 and 30, all the whole numbers between 5 and 30. And let's say that y equals x dot squared minus 40 times x plus 400. X squared minus 40 times x plus 400. Okay, so I've got my x and I've got my y. Now I just want to plot x comma y, and we get this kind of a curve. However, what we want to be able to do is maybe use the data that's used that created this graph. Over here, you can see that you've got x and y are separate here. But here, they've essentially put them into a single array and then plotted them. And maybe we want to use that. So if I want to use one of those numbers or find out one of those numbers, I can do it. But I'm going to have to put those numbers into an array that is a double array. So because there's two numbers coming out, let's call the two numbers coming out A and B, and let that equal G input. Let's see what it does for us. Whoops. Didn't mean to hit enter yet. I lost my plot. I need to get my plot back here. Where is it? All right, let's try this again. Okay. So now I've got my G input. Dang it. I need to go plot XY again so that I have my plot. And then I'm going to do my G input. There we go. And what this does, when you hit G input, notice that there's nothing happening down here. But when you bring your cursor up to the chart, it actually puts a little crosshairs on there that you can choose different parts on the graph. So if I come up here and choose this, come up here and click this, well, it's actually not doing it by clicking. But if I come up here and put my crosshairs on there and hit enter, then it will tell me what the values are at the graph at that point. It says that A, which is the X, is going to be 11.847, and the B was 67.4920. So it's a really quick way to figure out where you are on a graph. So if I go to G input again, you come up here and I just want to know what is this point right here. Set my mouse on there. And then I come down and I hit enter. Oh, I didn't like that one. I missed it apparently. You have to hit the function. You have to be on the function actually. Here we go. Come on. Maybe I have to click on it after all. Dang it. There we go. So now it's giving me numbers. Actually, I had two places. But anyway, you can get multiple points. You got to come up here after you hit G input and click on things and get values, and that can be very useful when you're trying to figure out what a number is at a particular point, what the coordinates are at a particular point on a graph. There are also ways that you can read and write data from files. So you can get things from another file on the computer, and then you can put things in other files on the computer. And there's a couple of different ways to do that. Let's see if I can... there's so many different ways here. So it kind of depends on what kind of file it is, actually. For example, you have one function called UII import. You have one called XLS write, XLS read. That's for Excel documents. There's wave read for wave documents, for essentially wave files. There's all kinds of different ways to bring documents in. And the best way is actually to just go here and to use this here. You can use your open here. No, let's not use open. Let's use, let's go home here. And let's go to import data. So to import files, if you go to your import data button here, then it'll give you an option to essentially click on some file. So if I have this MATLAB file, for example, and I just open it, it'll just do it automatically. And then you can open it, and you can actually look here. If you generate the MATLAB code, it'll actually create the code for doing that. So it's using what's called the load function, because things that are inside of MATLAB, you can use the load function, because .mat file is a MATLAB file, and you're good to go. However, if you're using a different one, if you're using a different file, if I want to import a JPEG file, for example, and I'll open this, and I generate the MATLAB code for that, then it's going to use import data file, an import data function. So I can import an image file. I can just go ahead and import an image file and be good to go. So let's try that. Let's use this particular function here. There we go. And the file that I want to read, goodness gracious. Goodness gracious, give me a break. There you go. How come I can't see it on my windows too far down? That's my problem. Goodness, it's dark in here now all of a sudden. I still can't see my window. Stupid window. It's not letting me scroll up. I don't know what's going on here with this thing. But anyway, so use this import wizard here, which allows you to import data in just at the touch of a button to import data stuff. And also you can do that for exporting stuff out. Let's see if I can figure out how to do the export. So importing data. But in export data, usually you're just going to use the write functions, or there's a write function for that. And it's RWRITE function for that. And then you can write things to files. So just lots of different ways, and we'll get more experience with that later on. But you can write to Excel files. You can write. You can create M files, of course. But that is the basic idea of importing things in, bringing things in from files. Now I am going to go ahead and end at this point. We're ending a little bit early. I'm going to go ahead and record this, make this recording, and then post this online. If any of you were trying to get connected with me, I'm sorry if we didn't get connected today. I tried to connect to Zoom, and I thought I did. I think I did, but nobody was there, so it was just me. So anyway, this will be online for you to see, and you guys have a good week. I will get your homework posted later, as soon as I can. Have a good one. Goodbye.